Welcome to this special BGP demonstration where I'm joined by Maris. He says he just wandered in here randomly and he claims to be just a regular Mikrotik employee. But this is very suspicious because routing wizards tend to be attracted by powerful high-end routers such as the ones lying on this table. Let's see, perhaps Maris can help us with our setup. These are 4 of our CCR2216 routers. They come with the most powerful CPU that we offer in our products, and besides the 25 gigabit ports, they also have 2 100 gigabit ports each. This one will act as our ISP, and then the next 2 are independently connected to it, so we have 2 connections to the internet. And then they are connected to a third router that could now potentially benefit from 2 uplinks. The 4th router, we will just use that one to run some traffic as if we had local endpoints. The question is, can we use BGP here?
Yes, but in most cases, end-user setups like this one does not require BGP. You can simply set up load balancing shown in previous videos. However, there are some cases where BGP can be beneficial, but it depends on several aspects, like are both uplinks from same ISP, do you have your own ASN and assigned network, and also what kind of services your ISP is providing.
Okay, in this setup we will have a single ISP. Could you please elaborate on what is ASN and assigned network, how that works?
So basically, Internet is a giant network consisting of many large and small networks. Large networks or networks united in groups with unified routing policies are called autonomous systems, and to those autonomous systems we have assigned a unique autonomous system number, which is unique to each AS and is used for external communication to other ASs. This number is also used to record the path to the destination and advertised in BGP AS path attribute, and is used for basic loop detection. There is also option to use private ISNs when ISP is providing specific services utilizing multiple links. In this case, public IP network is assigned from ISP's own range, and the network is always routed through ISP's network. This kind of setup can be utilized to provide services like intrusion detection, DOS mitigations, to protect the servers, and so on, but that is outside the scope of this video.
Alright, so as a home user, I wouldn't be missing out on this?
As a home user, most likely you will not be able to get ASN, but if you already have ASN and network allocated, then BGP and connection to multiple ISPs are absolutely necessary. You can even become a small service provider yourself, or even become a transit provider.
And if I wanted to do that, how could I get my own ASN and an allocated network?
Regional internet registries are responsible for ASN and network allocations. In Europe it is RIPE-NCC, ARIN for America, and so on for other countries. Typically, end users do not allocate directly from regional internet registries. There is specific hierarchy. First there is a regional internet registry, then there is local internet registry or national internet registry, which is also the ISP, and then only the end user. So the end user typically gets the allocations from national or local registries. And if you are the client of the large ISP, most likely that will be the one that is allocating also the ASN and the network.
What about the availability of ASNs and networks? Can anyone get one?
Not really. ASNs are assigned to organizations that are of certain size, must meet certain criteria, before local governing authorities decides to give you the ASN. When you have ASN, you can get networks. As for networks, mostly internet registries say that IPv4 address range is exhausted and you can get only IPv6, but that is not entirely true for the end user. And by the end user I mean the organizations, ISPs and so on. So there is still a chance that you might get the IPv4 range from your local registry.
All right, let's try some configuration. Presume I was able to get ASN and a network. I want my local services to have public IPs. Can we do something like load balancing?
Sure, actually BGP configuration itself is nothing complicated. Hardest thing will be to understand the concept and apply routing policies. So let's first do the basics and set up BGP instance. Even though version 7 does not have specific instance configuration like other vendors or RouterOS version 6, we can use the template configuration for specific instance. RouterOS version 7 is using router ID to determine automatically to which instance session will belong. Template concept was introduced to better manage dynamic peers. There are quite a lot of users setting multiple instances either by mistake or intentionally and wonders why BGP do not work as intended. I'll demonstrate it later. So next in the list is to set up BGP network. For that we will use address lists. As you can see, we have added the black hole route, and it is necessary for synchronization and protection against loops for free.
That is interesting. How does the black hole route accomplish that?
So basically when traffic is routed to your gateway from the internet and you don't have any IPs assigned from that subnet, black hole route will simply drop those packets. And so here's the protection for free. So next up we can add the filters. So if we do not set this filter, we become a transit provider. For example, there was one case when whole internet was routed over one end user setup because of bad policies set by him and by his ISPs.
Wow, I didn't know that's even possible.
Basically, in modern days, it's not possible anymore because ISPs are now setting up routing policies very carefully.
All right, good to hear that.
So now we are ready to set up a BGP session. And now if we go to Sessions menu, we can see established session with our ISP. And if we go to Advertisements menu, we can see that we are advertising our network.
So is that the connection to ISP 1 working?
Yes, and now we are ready to set up connection to ISP 2. So at this point we have both connections to ISPs and both our edge routers are advertising our networks. So from here we want to set up OSPF between all three local routers to distribute the fault route from both edge routers.
All right, is the OSPF the common way to do this?
No, you can use any IGP protocol, even static routing. Static routing can be done on very small networks, but anything larger will be a nightmare to manage without any kind of IGP. So now at this point we have ECMP route balancing upload traffic via both links. And download comes into one of the routers which is closer to the destination and this black hole.
We're just getting started. Come back for part 2 where we complete this.